Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at the definition of the derivative with a trigonometric example. And the example I'm going to use will be, I don't know, let's do y equals 5 cosine of 3x. So the first step would be to plug in. So if I plug into the definition of the derivative, which I'll write that off to the side just in case you forgot, is f of x plus h minus f of x all over h. And if I plug in, I'm going to have limit So the first step in every limit is to plug in. When you plug in, you're going to get 0 over 0 and indeterminate. Now here you can't do any algebra, but you can use trig identities. You can use the a plus b identity, but that's a lot more work. The identity I'm going to use is this one here, and I'll write it in blue. Cosine of a minus cosine of b is equal to negative 2 sine a plus b over 2 sine a minus b over 2. Whoa. Alright, so when I plug in, I'm going to have this whole expression be my a, and this be my b. Be my b, huh? That's funny. Alright, so when I plug in, I'm going to get, oh, I should have factored this negative, or this positive 5 out front. You see how there's a 5 common to both of those? So if I pull that 5 out in front of the limit, the next step would be 5 times the limit as h approaches 0 of negative 2 sine a was what? 3x plus 3h plus b, which is 3x all over 2 times sine of the difference of those two things. So 3x plus 3h minus 3x all over 2. And all that's still over h, but for now, let's see. What can we do? I'm going to simplify what's in here first. Hopefully you can see that I have a 3x that's negative right there and a 3x that's positive that are going to cancel. And when I rewrite this step, it becomes negative 2, oops, that negative sign's kind of high, down, sine 6x all over h. If you were to plug in, you still would get 0 over 0 at this point. But I'm going to refresh your memory on a certain identity that occurs with trig limits. I tend to use boxes. You can use watch my video for trig limits. If the box approaches 0 of sine box over box, that equals 1. The same holds true if it's box over sign box. Either way, as long as the box goes to 0, they equal 1. Alright, so it'll be too hard to make this h look like this expression here, but I can make the denominator h look like this 3h over 2 pretty easily if I multiply the bottom by 3/2, and if I do it to the bottom, I also have to do it to the top. And what that allows me to do, these 2's will cancel, and I have a negative 3 times 5 is a negative 15 constant. Limit as h approaches 0, and then I have sine of 6x plus 3h all over 2. And I'm going to write another limit because the limit of the products is equal to the product of the limits. Basically means you can just do them separately if you want to if they're multiplied. And then here we have sine of 3h over 2 over 3. Dagnabbit. Yes, I did just say dagnabbit. So, because these two things are the same thing, and we have them going to 0, right? There's your box, and there's your box, the same thing, and because of the h going to 0, the whole thing goes to 0. We can then just say the whole thing will go to my good friend 1. And the left side then needs to be reevaluated. If the h goes in, then I have 6x over 2, so it would be a negative 15 sine of 3x would be our final answer. In a different color than we started. Alright, I hope that has clarified any doubts that you might have over trig limits, and make sure, or actually this is the definition of the derivative using trig function. You won't need to use a definition of the derivative after this section. It's used as an introduction to derivatives. You will learn that there's a shortcut way for doing derivatives, different power rules available to you. Thank you, and have a nice day.